Hello. Good afternoon, everyone. Can someone hear me?
All right. Good afternoon. Yes, I can hear you kindly. Good afternoon, everyone.
Yeah, good afternoon.
Good afternoon.
All right. You're welcome, Clinton Nkweke. I don't know if I pronounced that correctly.
Yeah, you got it.
All right, that's fine. Good to have you here.
Mr. Clinton, welcome.
Good to have you too.
Right.
Okay, the moderator. Who is the moderator? Is the moderator available? Hello. Okay. Yeah, I think it's time. Okay, up to you, Samuel. Samuel will be. I'll be a co-host to Samuel. That's it. And our speaker, our external speaker is Mr. Clinton. Yeah. So welcome everybody. I think we can just start because of time. I think we can start by introducing ourselves. Please, can everyone open our camera? Let's meet you.
Good afternoon, everyone.
Yeah, good afternoon.
My name is Alex Michael. I'm a DevOps engineer here in Lincoln Dev Center.
All right. Yeah, welcome.
Please, can everyone hear us?
Yes, I can hear you. I can hear you.
No, I'm talking about the people that I muted and off their camera.
Okay.
I want to make sure everyone is connected. Okay.
Yeah, I can hear you.
Yeah, I want us to introduce ourselves. That's why I want us to, because we have new people. I don't know. Patients. Okay, I think we can just introduce ourselves.
Okay, good afternoon, everyone.
Good afternoon.
My name is Larry Balogun, DevOps engineer with Income Dev Center.
You're welcome, sir.
Thank you, sir.
Okay, let me go. My name is Clinton Nkweke, a technology consultant and a DevOps engineer with Z-Host Consulting.
I'm an infrastructure engineer and DevOps with Income Dev Center. My name is Ken Deodedo.
That's great.
Good afternoon. My name is Adiri Omogwajo, infrastructure and DevOps engineer intern in Bincom.
You're welcome, sir.
Thank you, sir.
All right, that's a nice introduction. My name is Samuel Ekele, also a DevOps engineer.
Okay, I think for now that's we that's connected. So I think we can just start because of I don't know how Samuel, how should we go about it? Who is going to give us a brief introduction and everything? I think we will do that of what we are here, the topic and everything.
It looks like I'm behind.
Yeah, Mr. Clinton, I don't know, maybe you have like a slide to share on this program.
Oh,
Okay, sorry. It looks like I'm behind. So I don't know if, can you confirm to me if you can hear me clearly?
Yes, we can hear you clearly. I even want to know maybe the moderator, so that in case they have to give permission to some certain things. That's why I'm asking.
can everyone see my
Sorry,
screen?
I don't know if
Okay,
anyone can
okay.
hear me.
Yeah.
So,
Okay, fine. So thank you for that brilliant introduction.
no, someone was speaking.
Hello.
Yeah, someone was speaking. So,
Okay, I think we lost on the connection. Okay, Mr. Clinton, can you give us some introduction on the topic today and everything? You can go first.
okay.
So I
Just
think you are the one sharing the screen right now, right?
you can see my screen, right?
Yes. It's coming up.
Okay. So basically, Git is a way of coordinating your workflow for the developers. So you can imagine building a house and you don't have a house plan. Maybe at a stage, you don't know when the carpenter is supposed to come, you don't know when the bricklayer is coming, everyone is just working, right? It will be more like a scattered event. So Git came as a process of checkmating everyone and making sure there is an orderly step in how the development environment runs among developers in the code flow. So basically, I love Git so much because of its level of organization and its ability to also reduce conflict among teams. So for the Git flow, the major two Git flow process we all know is the centralized flow. So for the centralized flow is mostly recommended for small projects, right? So I can maybe want to build a calculator app and it just involves two people, right? So a centralized flow can be set up. This is like the image. So this centralized flow is that the central repo is there in the cloud and 2 or 3 more parties are pushing same code. So if I'm working on the notification and maybe Samuel is working on maybe logging, right? Because it's a small project, I can easily push to the central GitHub repo. And after working on my notification, Samuel can also push his login to the GitHub repo because it is a small project. It can accommodate that. But one of the little disadvantages of this containerized, of this centralized GitHub workflow is that for broader projects, conflicts can come in the sense that first, the cloned repo is not in your machine, right? Because it's all there in the cloud. So I don't have a copy of the original GitHub, the project in my machine. So I just push what I have, Samuel push what he has, and the project moves on. But another turn down of it is that once the system, maybe the central repo crashes, the project is gone because we don't have the copy in our local machine. Like this, like the symbol that represents it. So another aspect of the GitHub to modify this, the distributed GitHub flow system came up. So a distributed GitHub flow system is mostly used for complex projects. First, it checkmates authority. So first, it checkmates authority, right? Secondly, the local copy is on my machine. So maybe I want to implement a function. I have to first clone the repo, initialize the project on my machine. Then after doing that, when I implement my function, we have what we call the main branch. And this main branch too is like the decentralized GitHub, the distributed rather. One thing I like about it so much is that everyone, like we as a team, choose the workflow. You understand? So we can have the master or the person that is in charge of merging, resolving conflict. So once we have it in our local local machine, if I want to push more like a function or a new feature that I just implemented, it has to be approved before it merges. So it keeps the central repo safe from code that are not tested, right? And also for new functionalities that has been implemented, maybe someone wants to push another function that he has worked on, maybe login, someone has to have a new copy of the updated repo. That means he has to pull my the updated version, rebase, before pushing his notification, right? So the distributed version, it checkmates security, and we all have the local copy in our machine. So if anything happens to the GitHub server, we all have our local copies in our machine. So it's really, really advantageous too. And aside from the main branch, we also have some level of, it also serves the advantages of rollback. Maybe we implemented a new feature in the application and along the line, we don't like that feature. We have our history. We can easily roll back these functionalities and get to the last changes too that was also implemented, and it track history of the push, the merge, everything is all tracked. So the distributed is what is commonly used for the current workspace, and GitHub workflow is really amazing because of the ability to resolve conflict among developers and its organized way of pushing up code. So, and also if we want to implement a new feature that on the application, we can just easily create a feature branch, more like a develop branch, to implement a new feature after being tested, also merge to master. So on this way, like the whole setup, the whole application is safe from breaking, is also safe for rollbacks, and it has some level of authority that no one can just come in to mess up the original code. I don't know if anyone has any other thing to contribute or question before I carry on.
Is there any question? We can as well drop our question in the chat box.
Okay.
Okay, I don't think there is a question yet.
Okay. Okay, that works fine. So, one advantages of okay.
Okay, someone has a question. So you can unmute yourself and ask your question, please.
Good afternoon. Thank you for that. But I wanted to just ask, as regarding, you are talking about how the application when the application has been pushed to GitHub, that's the different version parts of the application are pushed to GitHub, and then the GitHub server crashes, and then you lose your application. I was thinking of the model of microservices. I thought there was a structure to avoid a scenario where a server crashes and the whole application crashes. That's supposed to be the concept of microservices. So how does that relate to this structure that you are explaining to us? That's this centralized model of deployment.
Okay, thank you very much for that question. That's a smart question. So microservices tend to solve features being independent, right? So if I'm working on notification and someone else is working on let's just say, you can name any feature, maybe email or SMS. So microservice is loosely coupled. It segments each functionalities, whereby if maybe your feature breaks, the whole apps does not go down, right? So microservice also solves that. But the centralized system, as I mentioned earlier, is for small projects, very small projects of 1 or 2, 3 people coming to work on a functionality. So if Kehinde Samuel is building an application and they are just both, right? So for such feature, Kehinde can push his own to the central repo. Samuel can push his code to the central repo, and they are just working. They don't have that on their local machine. So once it crashes, it's lost. That is the structure. That's why the distributed system came in for a more complex project. And distributed system also came in to solve that, whereby Samuel, Kehinde, Clinton, and everyone has the copy of the entire project in their local machine. All they just need to do is to pull the latest update, rebase, and push, right? So we also have someone that controls, so the entire setup depends on the team. We also have someone that controls merge requests to the main branch for more like security and access control system. So I don't know if that answers your question.
Yes, sir, it does. Thank you.
Okay, you're welcome.
Sorry, before Mr. Clinton, are you trying to share your screen or something?
Okay, maybe I'll just stop to share. Can you still see my screen?
No.
Okay. So.
Okay, we can see now.
Okay. So this is like a graphical representation of it, whereby 2 or 3 parties both push to the main. This also it. This is a centralized workflow. 3 people, they are pushing directly to the central repo. So once this is lost, the whole project goes down, right? So that's why we have the distributed. The distributed came to solve that. If anyone has question, you can come up with your question before I continue.
Okay, let's leave the question to the end of the of the lecture.
So all right. Yes, the question can come in as it speaks. If you have questions, you can drop it in the chat box, and when it's done with this presentation, we can start with the Q&A section.
So, okay, the next will be the core concept of Git flow. So, for this Git flow, there are some vital things you need to know, which is the branches. We have what we call the main branch. This main branch represents the accumulation of approved and thoroughly tested code, right? And it also allows well-vetted source code to the master branch. That is the first, which is like the main branch. Just call it the production environment, because that is the last resource to production. Then after that, the next we have is the develop branch. The develop branch is whereby you want to implement a new feature, right? So it also acts as an integration branch to the ongoing development effort. And development branch can, like, developers can merge their feature to also the develop branch, and it's also stable enough for the staging environment. So for the master branch, is highly secured because it's the last source to production. So if you want to implement a new feature, you just say git checkout. That should be your new feature. Maybe you want to implement notification, email setup, email sending on that application. You want to implement some new features you just want to try out. You will not want to risk the integrity of your code base that that maybe has existed for like 10 years, right? So you check out a new feature branch and you work on the functionalities of those branches. Now, not all branches stand the test of time, right? So some branches can be created for after developing the features. Such branches can also be deleted because it's not needed again. Because after you have created, you have tested your new functionalities and you love it, right? And it serves the purpose of it. Then you merge to the master branch or the main branch. So merging to the master branch or main branch means that the code is well tested, the code is vetted, and is ready for production. Then another one we have also is the supporting branch. The supporting branch carries the feature branch and is created for the development of specific features and enhancement. We also have the, it encourages isolated environment for feature development, just as I mentioned earlier, and it's merged back to the develop branch upon completion. We also have the release branch. It facilitates the preparation of new releases. Maybe you have version, iPhones now, they have a lot of versions of software upgrade. Maybe this one can be version 2.0, version 3.0. So once you want to release a new version in your application, you can create a release branch to facilitate that new version. It's also born from the develop branch when the code base is ready to release candidate testing. And it finalizes versioning and release related tasks before merging to the branches. We also have what they call hotfix branches, right? So before the whole cash crunch, you heard about how so many bank apps went down because of maybe so much influx of users trying to access their funds online or rest. So in such scenarios, you can create, maybe there is an urgent problem that is needed. You can create a hot fix branch, right? So the hot freeze branch is being created to fix critical issues in the production code, right? So maybe you want to authenticate or you want to do withdrawal, and all of a sudden your app breaks. You don't even know what is going on. Instead of just coming to scatter your entire code base, you can just create a hot fix branch, fix up, code out something that can tackle that problem heads on. And it can also be merged back to the master after is created and serves its purpose. It allows swift resolution of critical problems without disrupting the ongoing development of the application that is currently running, right? So apart from these branches, one of the major things you need to also know in the Git flow is structures before you start your project, right? So if I want to start my project, I can say, I would first say git flow init. So this initializes entire project to my local machine, giving me a copy with on my local machine with my name. So it guides the user through the setup, fostering consistency that of the branch that are managed. You can also say to also start a new feature. You type your Git flow feature, start new feature, name the name of your feature. You can if you're done with the feature, you make to the master, you can also delete. So if you're starting a new release, there are commands that you use. You can say the Git flow release start, the version number, you set that up too, right? So all these commands, you can actually see them in initializing your project. So what I will go directly now to the advantages of Git flow. Very, very important. Very, very important, because you cannot come to build a house without a plan. If you're coming to build a house without a plan, that means you should be heading for catastrophe. So advantages is that it encourages isolation of features, and isolation of feature means like development of features in isolation, minimizing conflict and simplifying testing. Sorry. So if I want to test for a new feature, I can easily test for that feature because it's well segmented, right? So it also makes the master brand stable and very consistent, because everything before a code goes to the master is well tested, is well vetted, and we know it's bug free, right? So versioning and release management is another section of it. Git helps to really do that. Just as I mentioned earlier, you can want to create a new release, you name it version 1.2, version 3.2. So Git has the history of these versions. Even though your version, after implementing it and you don't like this version, you can easily do a rollback to the previous version, right? So it makes your version and your release very manageable and orderly. It also fosters collaboration, which we all know. So for me, the project I'm currently working on, the developers that are on it, so after them doing their code, the code review and the rest of them, we make sure it's being vetted before I approve merging into the masters. So it fosters a lot of collaboration between the team, everyone knowing their rights, their kind of assets they have, and creating a pull request and the rest of them. So it's well structured and it creates a lot of collaboration among the team members, right? So we also have challenges and consideration. So while it offers numerous challenges, it's also essential that for you to recognize that it's not it might not be a one size fits all solution, right? For the project size, the team dynamics, release frequency factors, and it should also influence adaptation of Git flow to the specific concept. So like what that is trying to say is that you can actually configure Git to fit in to your project. You're in charge, right? You're in charge. You can set it up to fit how you want your project to flow. Yeah, so it's basically on you to do that, right? So those are the common advantages of Git and the challenges that it might not really fit in everything. So you have that authority to, I want this, I want this, I want this restriction, I want this asset. Before someone should pull, I should grant that permission. Before someone should, so you're in command, right? So Git gives you that level of authority to make sure your production environment is not messed up, because products are highly critical. Just imagine maybe a new intern come to your team and you don't have a structure, and he implements a function and just push, and it crashes the production database. Let's just use Meta, because there was a time Meta went down, right? And they went all over the world. Just imagine an intern comes out and and pushed to the production and the whole code is crashed, it can cause the company to lose millions of dollars, right? So you wouldn't want that, because you being the maybe like the DevOps engineer might lose your job because of such costly errors, right? So you have that authority to restrict access, grant access, so you can configure it to fit in the specification of your project. So in conclusion, but like you can ask questions while I'm going through this. Sorry.
If you have questions, you can raise your hand.
So, okay, if there is not, let me just conclude. In conclusion, Git flow is also a powerful methodology that orchestrates the branching, merging strategies in Git to streamline collaborative development, and it's also a systematic approach to managing features, release, hotfix, provide teams with clear and organized framework for efficient software development. So as you apply Git flow principle, remember to assess and adapt them to the unique need of your project. If you have any question, you can ask.
Okay.
Yeah, good day. Thank you, Mr. Clinton.
Yeah.
Okay.
My question is, how do we structure Git to roll back on a production error? Like maybe there's a deployment to a production and later you discover there's a bug or something. How do we structure Git so that in time we can roll back to the previous production or the previous stage in production?
Okay, that is a wonderful question. First, Git was created to prevent error. So when before that, the first step to block such error is that before your code is pushed to the master, it must be tested, right? Before merging. Then after you have merged your to your production environment, and at a stage you want to put up a new release or a new hotfix. So Git, in Git repo, it has histories, right? So you can just easily, just a moment, let me even show you. Because this command, right, you don't really know. As a developer, one of the tools I use very well, I use this tool to frequently get command, right? Because you must know how to use your resources very well. So definitely you will have the documentation of all the commands you need so that it makes it easy, right? So we have the revert command, as you can see here. You can easily revert such command, naming because definitely once after you finish your coding, right, and you git add, you git commit, right? So once you git commit, you put up more like a name for that commit you have made. And naming convention is very, very important in Git, right? So if I did an update on notification, I can just, once I'm committing, I can say notification update. So I've written my commit message as notification update, and I've pushed to the central repository, right? So pushing to the GitHub repository, it captures that commit. So I can easily say git revert to get that functionality back, right? We also have the git reset, that's that add, which is more like forcing it to come out, right? So these two commands you can use to get a rollback on your functionality. So, but before you get that, that's why we have the master branch. Before your code, you don't have to wait till your production environment is messed up. It's not really good. Before you push any code to your master, you have to do your regression testing. You have to really test your environment from, that's why the develop branch is there, right? And the feature branch. You really have to do all this testing to make sure anything that is going to the masters is cool. So once the master is running, we know that, oh, this is a new version. Maybe you want to do a better version, now maybe version 2.0. You now create another version of release. Then you put up your code there, you push. So the commit message stands as an important aspect that it can capture that particular commit and revert it using the git reset and git revert command. I don't know if I answered your question.
Yeah, yes, thank you.
Okay, you're welcome.
All right, we have one more question from our online audience. The question says, what are the latest trends in Git workflow strategies, and how can teams adopt them?
Okay, the latest trend is following best practices. So just as I mentioned earlier, if I'm to set up a project, the first thing I want to do is access. So I will definitely me being the DevOps engineer, I'm managing the project, I will have the highest access. So having the highest access is that I will be the one to authorize merge requests. That is one of the best practices you can implement in your workflow, and it's also a world standard practice. So it's good the team lead or the project manager has the ability or is only granted the access to merge. So if a student or a developer does all his coding, he also sends in a pull request, right? So I'll also be the one to authorize the pull request and the merge request. So those are the current trend in Git, setting up these security measures so that anyone cannot just come in to mess up your code. You can also also restrict some access. Maybe there's some critical code that you don't want developers to see. You can restrict access from those level of developers to those particular code by giving some security measures. Definitely, once a pull request is created, it hits you on your mail. Then you go to your GitHub repo to authorize or decline. So following these best practices saves you a lot of energy, saves you a lot of manpower, and it gives you maximum security. So those are the current best practices you can implement in your workflow. And for organizational code, I would really recommend we use the distributed system, right? So that everyone has the copy of the work on their system. It's also a very, very good practice. Yeah. So I don't know if that answers your question.
Yes, that's good. That's correct. We have another question in the chat box, and the question says, what are some best practices for Git commit messages, such as meaningful description and linking to issues or tickets?
Okay, thank you so much for that question. That's a very powerful question. So the best practices is that most of us in the tech world know moving from one job to the other is very, very common. So having a good descriptive commit message makes it easier for the team that want to inherit the code base to have a better understanding as we transition. So if some code base is as old as 30 years, 40 years, right? But you also have new developers coming up to read through this code base within 1 to 2 months. They have a general picture of what this code is talking about because of good commit message. It's also advisable you have comment, very, very good comment. So I can write a code and put up good comments on this code describing what this code is doing. So if I'm doing a code maybe for email, I can put up a description, email sending, just put on a good hashtag with good message, and also committing with also a good message that describes what that code is doing or what that commit is doing, so that if a new developer comes, he can easily onboard himself without having stress on it. So we should know that the code base is what fetches our money, because these are the engine room of the whole company's operation. So it's just like you're having a car and you don't want to maintain your engine. You can have a very fine body, right? But any day that your engine knocks, maybe stops you on the third mainland bridge, even though you spray the car that day, the car is not moving because you didn't do your due diligence on the engine. Same thing. So it's about your quality of code, how you arrange your code, how you dress your code. So if you're moving from that role, the new person coming to take over can easily get to understand this code and carry on from where you left. So good commit message is very, very important, and good comment on your code is very, very important. I don't know if I answered your question.
Yes, that's correct. Thank you very much for that answer. And to add to it is, when you are crafting your commit message, or rather writing your code whatsoever, remember that you are not going to be the last person working on that code. There are other developers that are going to come in future. They should be able to know what you do as at when you do it exactly. All right, so that when Git is trying to manage the version of that or the state of that software at that time, you should be able to identify with that message that, okay, this is exactly what you do. And there is this practice that we do when you want to add changes, when you want to stage your changes, right? Generally, some developers will just do git add, and then you add all your files at the same time. You can still go a little bit, because if you make 2 changes in 2 files, it's not going to have the same commit message. All right, it's going to have it's supposed to have clear, for clarity, it should have 2 commit message. You can commit them at different times, all right, so that you have different commit for them, so that the next developer that will come will know that, okay, at this time, what you did was that you create a hamburger, or you design the color of this at this time. That's what you do, all right. And before you can be able to and ensure that your commit should be just brief. It should just be little commit bit by bit. You don't make big changes and before you commit, so that whenever there is a problem, that the small commit that actually triggers the problem, how to revert back, remove that, and then figure it out easily. As you are writing your code, just have it at the back of your mind that you are going to leave it in the next minute. Another person is coming to work on it, and the person will understand exactly what you do there.
That's perfect.
So thank you. If there's no any other questions, if there is any, can you please raise your hand if you have any question? So if there's no any other question, thank you, Clinton, for that presentation. It's incredible. We have done so much, and it looks like there is nothing more to add. In fact, you've touched all the areas and understand a whole lot of things. And I believe every one of us here does the same thing. The next thing, we're going to have our second speaker. And in fact, we are not saying only questions. If you also have a contribution, please, you can contribute. We are here to learn, all right? So in this journey of tech is a lifelong process. It's a lifelong learning process. So everybody is learning. If you have contributions, you can also raise your hands. You can contribute, you know. And if there is no contributions, we are moving on to the second speaker. As I've said earlier, Clinton has done so well that he has touched almost all the areas, and he make it look like there is no much left to talk about. All right. So at this point, second speaker will be me, and my name is Samuel Ekele, and I'm a DevOps engineer in Beacom Dev Center, and I'm also going to speak on the same topic. I'm going to also speak on the same topic, understanding Git workflow strategy. It's not like I'm going to add to anything that Clinton has just mentioned, but it's just a touching areas and make it more conversational, all right? If you have any questions, you can drop it in the chat box, and then we can tackle it later, and Clinton also will help us, you know, if the questions are so difficult for me to answer, all right? So thank you, all of you. Thank you all for joining us today, for being here, actually. And thank you, Clinton, for a job well done. Above all, I want to extend my sincere thanks to Beacom Dev Center for its noble mission of providing a platform for novice, you know, to thrive, and offers them the opportunity to grow and make meaningful contribution to the tech world and also to the society. So please, I'm not able to share my screen. Who have the host privilege to add me to make me a host?
The moderator. Mr. Clinton, please, you can close your sharing.